All right, so in the previous chapter, you learned about the system development lifecycle with specific reference to database system. The system design stage involves logical and physical design. They are developing data and process models from the proposed system. While this chapter focuses on the system design stage, and this chapter focuses on the logical design for the development of database system. And we have two main objectives in this chapter. So first, we should describe the two commonly used logical modeling tools for this system design. They are the previously discussed two models, ER modeling, that is entity relationship modeling, and data flow diagram. And second, I'll provide you a specific guidelines using a event-oriented approach to facilitate the construction of ER models and DFD models for business scenario. All right. So first, let's consider a business scenario. Managers supervise employees. Well, this is a business scenario involves events in which certain entities are involved. It is information about these events and entities that we would like to represent in the database. So, the aim of logical data modeling is to capture the information about all events and entities and to indicate how these events and entities are related, such that a database system can eventually be constructed to store data about those events and entities. So in the logical data modeling, sometimes it is called the conceptual data modeling. The analyst attempts to develop a conceptually accurate presentation of a real-world business scenario. The goal is to capture the semantic or meaning of the reality, which is why this process is also referred to semantic data modeling. So while a number of logical modeling approaches have been proposed, the one that has gained widespread acceptance in the information system community is entity relationship modeling. And this was developed back to early 1970s. So let's get to know some fundamentals of entity relationship diagram, ER diagram. The most basic form of ER approach uses rectangles to present entities and diamonds to represent relationships between entities. Anything that the organization would like to maintain information about is considered an entity. So common entities include external parties like customer and vendors, employees within the organizations, or objects such as inventory and cash. business events are like the sales orders, purchase orders, maintenance requests, payments to external parties, etc., etc. Well, here relationships are nothing but the association between entities. So first of all, let's consider a very simple business scenario regarding a public accounting firm. This scenario is managers supervise professionals. So analysis about this business scenario suggests that there are two entities that are related to the act of supervision. The resulted ER diagram is shown in this slide. There are two entity symbols, managers and professionals, and one relationship symbol, that is supervise, and it is used to link the two entities. Well, it is convention to label the relationship so that the relationships reads from left to right. So this diagram indicates that managers supervise professionals. And now let's expand this business scenario. Further description of the processes in this accounting firm reveals that professionals have skills, and it is necessary to keep track of which skills a professional has. So the initial ER diagram is modified to include a skill entity which is linked to professional entity via a have relationship. The modified ER diagram now captures information about another data item of interest, that is the skills of professionals. And now let's expand this example business scenario further. The analyst determines three more extra things to be recorded. 1. Jobs are performed for clients. 2. Professionals are assigned to jobs. And 3. Jobs need equipment. So this diagram, this ER diagram on this slide can be further modified to show the jobs, clients, and equipment. So with these additions, you can see the ER diagram can depict many aspects of the operation of this firm. So the basic ER diagram shows only entities and relationships between the entities, only entities and the relationships. But it doesn't show the type of relationship in terms of relationships of cardinality. So now let's learn the extended version of ER diagram, that is, extended entity relationship model. So you might recall our discussion about relationship cardinality in the previous chapter, where we discussed how relationships could be either one-to-one, one-to-many, or many-to-many. So the basic ER diagram in the previous slides, showing the managers supervise professionals, doesn't show whether a manager supervises one or many professionals, or whether a professional is supervised by only one or more than one managers. The basic ER model also doesn't indicate whether relationships are mandatory or optional. So now let's return to the manager professional diagram. Well, the 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 basic ER diagram also doesn't show the attributes of each entity and relationships, and in particular, the primary key of each entity and relationships. So, EER model, extended entity relationships model, show all of these characteristics. So in summary, EER diagram shows cardinality, optionality, and attributes. So let's discuss how these three characteristics are depicted on the EER diagram. Consider the relationship between managers and professionals. If a manager supervises exactly one professional and each professional is supervised by exactly one manager, the previous ER diagram is accurate with respect to the cardinality of the relationship between managers and professionals. But let's assume that a manager can supervise many professionals. A manager can supervise many professionals. And clearly, this is a more realistic assumption. But each professional is supervised by exactly one manager. So in other words, the relationship between manager and professionals is one to many. So this relationship can be depicted using the ER diagram and the EER diagram showing on this slide. And as I said, one manager can supervise many professionals. Now you can note the crown's foot at the connection to professionals entity. The purpose of this crossfoot is to show that many professionals are supervised by a manager. The relationship between managers and professionals can be read both ways. You can read it as one manager supervises many professionals, or many professionals are supervised by one manager. And now let's modify this diagram to show that it is possible for a professional to be supervised by more than one manager. So if so, the relationship between managers and professionals is many to many. And in that case, we just need to add the crossfoot to the manager side. We just need to add the crossfoot here. So this ER diagram means many professionals can be supervised by many managers, or in other words, the relationship between managers and professionals now becomes many to many. All right, next, let's see how optionality of relationship is depicted in a ER diagram. An entity's participation in a relationship can be either mandatory or optional. So in this managers and professionals example, let's assume another rule. That is, a manager may be supervising many professionals or none at all. And in real world, it probably means a newly hired manager may not yet be assigned to supervise any professional. And in another case, a professional must always be supervised by at least one manager and possibly by many managers. So in terms of ER diagram, we need to show that the participation of professional is optional and the participation of manager is mandatory. So in the ER diagram, the optional participation of an entity is indicated by a circle. That is this circle here on the relationship line leading to the entity. And mandatory participation is indicated by a bar or a vertical line on the relationship line leading to that entity. As you can see, this vertical line on this slide. So this slide shows That's the participation of professionals in the supervisor's relationship is optional, and the participation of managers is mandatory. So this diagram reads as managers may supervise either none or many professionals, and each professional must be supervised by at least one and possibly many managers. All right, finally, let's see how the ER diagram can be enhanced to show the attributes. The attributes are shown in the ER diagram using ovals attached to each entity or relationship. So in this figure, let's assume that managers have some attributes like the manager number, which is the primary key, as well as name, office number, phone number, and email. Professionals have the professional number, which is the primary key. Name, phone number, date hired, these four attributes. There are no attributes unique to the supervisor's relationship. Now, the ER diagram includes the attributes, and you need to note that the primary key for each entity is underlined. But the attributes are often omitted in a large ER diagram because the diagram would become extremely cluttered if each entity's attributes are shown on the diagram. So this is a quick summary. Now you should be able to extrapolate the following entries for variations in cardinality and optionality for entity A. Oh, this is entity relationship model. Now let's continue on the data flow diagram. The ER modeling is data-oriented in that it is aimed at logically showing the data structure aspects of the environment under examination. In contrast, logical process modeling is aimed at showing the ways in which data items are modified, that is, the procedures that modify entities. And also, as we discussed in the early chapter, a popular tool for logical process modeling is data flow diagram or DFD diagram. DFDs are useful for modeling and understanding process as well as the flow of data relative to process in a system. A DFD diagram uses only 4 symbols. They are circles to represent process, arrows to represent flows of data, open-ended rectangles to represent stores of data, and the square box to represent an external entity. Data flow diagram can be used to describe processes at different levels. At the highest level, it is called context diagram. The context diagram treats the entire information system as one process and shows the inputs to the system from external and internal entities and the outputs from the system to external and internal entities. Data stores are not shown in the context diagram because stores are internal to the system. This is an example of context diagram. The context diagram are intended to be used by higher level managers, such as controllers or the CIO, Chief Information Officer. These higher level managers just need to know the inputs and outputs and treat the entire system as a black box. They don't necessarily need to know the details inside this system. Well, returning to our accounting firm example, consider an information system for recording client jobs and the assignment of professionals to jobs. The system accepts inputs from two entities, one external and one internal. The external one is clients and internal one is professionals. Clients specify the requirements for each job. Professionals provide input regarding their skills and their availabilities. Outputs from the system comprise acknowledgements of jobs to clients, jobs assignments access to professionals, and the reports of jobs created to managers. So, given the input process output orientation of the context diagram is from left to right. All flows are shown going from left to right, and all flows are labeled. Flows returning to an entity that provided input are also shown from left to right by repeating the entity on the right side of process. So this is the highest level of DFD diagram, context diagram. After that, we need to examine some details. So let's look at level 0 of DFD diagram. At this level, level 0, it shows the major processes in the system. The interaction, you can also see the interaction between the processes as well as the data store used to store data. The reason why it is calling level 0 is the processes shown in this level are labeled 1.0 and 2.0 and so on. You can see the job, record job process is shown with 1.0 and assignments of professionals it's shown as 2.0. That's why it is called level 0. So this level 0 DFD diagram shows two main processes involved. They are job recording process and job assignment process. It also shows the data stores. Data stores accessed or updated by the process. Every data flow is labeled. The record job process gets input from the client, accesses the client data store, and adds an entity to the job data store. The assign professionals process accesses the jobs, professionals, and the professional skills data store. It also receives input from professionals regarding their skills and availabilities. This process adds an entry to the job assignment data store, which shows the specific jobs to which each professional is assigned. The record job process generates a job acknowledgement, which is sent to the clients, while the assign professionals process generates a job assignment sheet, which is given to the professionals and also reports which are given to managers. At subsequently detailed level, processes are broken down even further. A level 1 DFD expands on each of the 0.0 process in the level 0 DFD. Well, as you can see here, level 1 DFD provides more details about what exactly is involved in the assign professional process. They include checking the skills of professionals, checking their availability, and actually making the assignments. So details regarding these steps are depicted in the level 1 DFD diagram. Unlike the level 0 DFD diagram. Note all the processes in level 1 DFD would have the process execution recorded in the table. In the level 0 DFD for job recording and assignment system, execution of two high-level processes need to be recorded in data store because they are the main processes that the organization would like to plan, to control, and manage. However, the purpose of the level 1 DFD is simply to provide more details regarding the steps involved within the particular level 0 DFD process. Execution of the check skills and check availability process are not each recorded in the data store because these steps are merely intermediate leading to the main step of actually making assignments. So while there's no magical formula for you to generate a good DFD, some general guidelines are provided. First, to determine the scope of the system. Second, to identify the process involved and the relationships between the process. Third, to identify the data stores that will be accessed and or updated. Fourth, labels all the DFD elements. And finally, to avoid unnecessary overlapping data flow lines. All right, now we have discussed the ER diagram and DFD diagram. Now we return to our question posed earlier. How exactly one go about constructing these models for information system? Many system analysts and designers would contend that the process of developing an ER model and corresponding DFD diagram is more of an art than a science. While there's some truth to this contention, but we still believe that following a structured set of steps will lead you to at least a preliminary set of ER and DFD models for the target information system. We first explore logical data modeling. While ER modeling is a generic approach that is widely used for designing a variety of information systems, let's consider how ER modeling can be applied specifically for designing data models for information systems. Well, here we would like to use a REA modeling, that is resource event engine modeling, to converge the ER and DFD models into a logical design of the information system proposed. So over the years, the REA framework has been extended and implemented by other researchers in this field. In the REA approach, the key questions to ask are what, who, when, and perhaps where. Answering the what question will reveal the event itself and resources that are affected. Answering who question will reveal the engines involved in the event. And finally, answering the when and where question will provide further details about the event. These are the details that will be helpful as we record the occurrence of the event. So again, let's look at the definition of REA model. REA model focuses on resource, events, and engines. Resources are economic resources that are assets of an organization. They are defined as objects that are both scarce, valuable, and under the control of the organization. Economic events are those phenomena that affect changes in resources, while economic engines are individuals that participate in economic events. The first and the most critical step is to identify the significant business events or process. What constitutes a significant business event? Well, significant business events are those business activities that management wants to plan, execute, and evaluate. These events are significant in the sense that the success of the organization depends on the successful planning, execution, and evaluation of these events. The two broad categories of business events are economic events, such as sales and purchases, and non-economic events. Economic events involve increase or decrease in resources, such as inventory or cash. The REA framework deals specifically with economic events that are directly decrease or increase resources, and it is well suited for modeling the business phenomena. The basic REA pattern shows resources, events, and engines with three types of relationships. These three types of relationships are stock flow, duality, and control participation relationship. So here, let me briefly introduce these three types of relationships. Relationships between economic events and economic resources are called stock flow relationships because they either increase or decrease the resources. In the economic exchange context, every resource increasing economic event will eventually have a corresponding resource decreasing or increasing the economic events. So this coupling between resource increasing or decreasing events is referred to as duality relationship, which can be thought of as give-take relationship. Finally, participation relationship define the internal and external engines associated with economic events. Internal engines are typically employees, while external engines varies depending on the type of events. For example, a credit sale event will have a customer external engine and a salesperson as internal engines. So this is these three types of relationship. Well, I think that's all of today's class. And in the next class, I will provide you with a specific guideline using event-oriented approach to facilitate the construction of ER models and DFD for a business scenario information system. So, before I leave, please let me know if you have any more questions.
No, that's all. Thank you, Professor.
All right. Thank
See
you.
you.
So I will see you next week. Bye bye.
Yes. Bye.